When we're solving log equations, they can fit into one of two types of equations. They'll either fit into the pattern of the log of something is equal to a number, or they'll fit into the pattern of the log of something equals the log of something else. And every single log equation, you should be able to get back into one of these two forms, and then we're going to be able to solve them. So I'll give you an example of each so you can see how we would solve them, and then I'll give you another example that's a little bit more complicated. So let's start off with something that's a log of something is equal to a number. So let's say I gave you the log base 2 of 4x is equal to 3. This fits into this pattern. The log of something is equal to a number. Contrast that to this example over here where I've got the log base 5 of x plus 6 is equal to the log base 5 of 11. So in this case, you can see I've got the log of something is equal to the log of something else. So the log of something equals a number, or the log of something equals the log of something else. So one way that you can solve this one over here is you can rearrange it into exponential form. And in exponential form, the base is going to stay the same. Then the exponent moves up here on the base, and then the argument becomes the answer. So that's just rearranging from log form to exponential form. And then we can just simplify. We know that 2 cubed is equal to 8, and that's equal to 4x. Divide both sides by 4, and of course, you get x is equal to 2. Now, the one thing we have to double check every single time we get the answer to a log equation is if I substitute x back into the original equation, is the argument going to be greater than 0? Because all arguments have to be greater than 0. If the argument is less than 0, then that solution that you found would be inadmissible. But in this case, let's check it. 2 would go back up where the x is. So the argument in this case, let me just change pen so I can write it. So the argument, if I subbed in x is equal to 2 back into the argument, so the argument would be 4 times 2, which would be 8, which is greater than 0, so the solution is acceptable. Okay, I'll give you an example a little bit later where it's not. All right, so that's how you would solve log something is equal to a number. On this side, we've got a log something equals the log of something else. And if you get to the point where your two bases match, then I know that if I've got the log of something equals the log of something else, I know then that the two arguments have to equal each other. So as long as my bases are the same and I have no other terms going on here, I just have log something equals log something else, then all I have to do is talk about my arguments. So x plus 6 is equal to 11, and then I'm going to subtract 6 on both sides. So x is equal to 5. Again, I need to go back up and double check in both arguments, if there's an x, is this 5 going to allow my argument still to be greater than 0? So 5 plus 6 is 11, so that is greater than 0. So this is an acceptable solution. Okay, let's try another one and see if we can fit it into one of these two categories. Log something is a number, or log something equals log something. All right, let's go down a page and see what we can get here. All right, let's say I'm talking about 2 minus log base 5 x minus 4 is equal to 0. In this case, before you even begin, I want you to take a look at the question and determine which category do you think it's going to fit into, and then keep working on it, manipulating the question until you get it into one of those categories. Is this a log something equals number, or log something equals log something else? Because I have a number hanging out here all by itself, I'm going to assume it's a log something equals number. So I don't have it in that form right now. I need to get it into that form. So one thing that I could do is I could get the number to the right-hand side of the equation. So I could subtract 2 on both sides. So I've got negative log base 5 of x minus 4 is equal to negative 2. Now I'm always uncomfortable having a negative in front of something that I'm trying to solve. So because it's an equation, what I'm going to do is I'm just going to divide both sides by negative 1, and I'm going to be left with log base 5 of x minus 4 is equal to 2. Now this is in the form of log something equals number. At this point, I can go ahead and rearrange it into exponential form. I've got my base of 5. I'm going to the exponent's going to be 2, and the argument's going to go over on the right-hand side. Now I solve. 25 is equal to x minus 4. I'm going to add 4 to both sides, so x is equal to 29. I want to double check to make sure that the argument here is still going to be greater than 0. 29 minus 4 is still a number greater than 0, so this solution is acceptable. All right, let me change pens. And let's try another solution. Okay, let's say I ask you to solve log of base 9 of x plus 3 plus log base 9 of x plus 6 is equal to log base 9 of 10. Again, before I start the question, I want to ask myself, which one of the two forms does this fall in? Log something equals number, or log something equals log something else? Because I don't have any numbers outside of the arguments of the logs, I think it's going to be a log something equals log something else. But it's not in that form right now. Right now I have a log, then a log equals log of something else. So what I want to do is I want to combine this left-hand side together using my log properties. And I know that if I have logs with the same base and I'm adding them together, what I can end up doing is just multiplying the arguments as a single log. So I'm going to rewrite the left-hand side as a single log. So log base 9 of x plus 3 times x plus 6. And then the right-hand side is log base 9 of 10. So now we're at the point where we have log something equals log something else. I only have one log on either side. All right, so at that point, just like we did above, I can rewrite my arguments, without the logs and just solve for my arguments. That's x plus 6. Quadratic, so let's expand it out. So x squared plus 9x plus 18 is equal to 10. And we're going to solve for this, so I need to just clean it up, simplify it. X squared plus 9x, subtract 10 on both sides, plus 8 is equal to 0. I'm going to see if I can factor this, so what multiplies to 8 and adds to 9, and we're left with x plus 8 and x plus 1 is equal to 0. And this gives me two solutions. The first one is that x plus 8 is equal to 0, so x has to be negative 8. And the second one is that x plus 1 is equal to 0, so x has to be negative 1. So now what we want to do is we want to double check to make sure that both of these solutions will actually work. So let's start with the negative 8. We'll go way back up here into the first argument. And if I plugged in negative 8 in for x, negative 8 plus 3 would give me negative 5. And that would cause this argument to be less than 0. And since the argument is less than 0, this value, or that solution for x is going to be inadmissible. So I would write that in there. I would say it's inadmissible because the argument would be less than 0. Okay, so this is an extraneous root. It's extra. It doesn't actually fit into the solution. Let's see if negative 1 works. Negative 1 plus 3, that gives us a value greater than 0. And negative 1 plus 6 also gives us a value greater than 0. So x equals minus 1 is the only solution to this question.